Okay, so the question is, if 12 grams of aluminum chloride is dissolved in water and reacted with 12 grams of magnesium metal, and if 9 grams of a solid product is collected at the end, what is the percent yield? What now? Yeah, hopefully it'll settle down in a minute. Okay, so the first thing we have to figure out is what the limiting reactant is.
First.
Okay. For that, we're going to have to do a mass-to-mass calculation from one reactant to another. The two reactants are aluminum chloride and magnesium metal. You have to read and interpret the problem to figure out what the two reactants are. Doesn't matter which of the two we start with. I'm just going to start with the first one that's listed here. I'm going to start with 12.0 grams of aluminum chloride. Now you have to be able to balance formulas. Okay, I'm not going to spend time going over balancing formulas right now because I wasn't asked to do that. But aluminum has a 3+ charge. Aluminum is a metal, chlorine is a nonmetal. It's going to be an ionic compound.
Al has a 1-, right?
Yes, chlorine has a 1- charge, so the formula has to be AlCl3. Capital A, little l, capital C, little l, 3. Okay, and we're going to start with putting that up by putting that over 1. For all of our stoichiometry that we've done in this class, we always start with the starting amount over 1. I need to calculate the molar mass of aluminum chloride. So we're going to have aluminum here, and we're going to go to the periodic table and find its atomic mass, and it's 26.981538. There's only one aluminum in the formula, so I'm going to multiply that by 1. 26.981538. And then I find the atomic mass of chlorine, 35.453. There are 3 chlorines, so I'll multiply that by 3. And I get 106.359. And that leaves us with 3 empty slots over here. We're going to add these two numbers together. And we get 133.340,538. Because of the empty slots on the right, those numbers are going to be rounded off. That's part of the rules or the way that I taught you to round off in addition. And then we're going to find a rounded answer here to find our molar mass. And it's 133.34. This 5 makes the 0 round up to a 1. 341 grams of aluminum chloride equals 1 mole of aluminum chloride. And from this equality statement then, we're going to build a conversion unit. So back up here in the problem then, we want to have on the bottom here the part of that equality statement that matches units and species with what's on the top here. So we're going to put that 133.341 grams of aluminum chloride, that's AlCl3, it's kind of sloppy, I'm sorry, on the bottom, and on the top is the other side of the equality statement, the 1 mole of aluminum chloride. This is arranged then in a way that we can cancel the grams top and bottom as you cancel x's and y's in algebra, and we can cancel the AlCl3 as well for the same reason. Now that I have moles of aluminum chloride, then I can do a molar ratio to go from one reactant to the other. For the molar ratio, I have to have a balanced equation. We are reacting aluminum chloride, which we said is dissolved in water, so that's aqueous, with magnesium, which is a metal, so it's a solid. Only mercury is a liquid metal. Well, there's actually another one, but we don't deal with it enough to talk about it very much. We need to know how to react these two. The first thing I guess I might want to check is to make sure that magnesium will displace aluminum. This is a single replacement reaction. I know this because I've got a metal by itself and a compound that it's reacting with. So magnesium needs to replace or displace aluminum. The question says that they're going to be reacted, so that's a really good clue. Just to double check though, magnesium on the activity series, the magnesium metal is higher on the activity series than the aluminum is. Okay, they're right above each other, so the magnesium is higher, so the magnesium metal will displace the aluminum ion here. So when magnesium displaces aluminum, we're going to get magnesium chloride. Magnesium is going to join up with the back of this, and we're going to have aluminum that's by itself. Now aluminum is going to be a solid, so now we know that the solid product in the problem is aluminum. Magnesium chloride, you can check your solubility rules to be sure, but it says here that chlorides are those are among those compounds that are soluble. There's an exception for silver, lead, and mercury, but this is obviously not silver, lead, or mercury, so this is going to be aqueous. We need to know, we need to balance this equation, or balance, sorry, not balance the equation, to balance the formula first. Magnesium has a 2+ charge. You know that if you look at your periodic table with oxidation numbers, magnesium has a 2+ charge. Chlorine has a bunch of positive charges, but we have to have a negative charge on chlorine so that we can have a neutral compound. And so the chlorine has a 1 negative charge. So to make those balance out, we're going to need 2 chlorines, magnesium and 2 chlorines. So MgCl2. Now to get a balanced equation, I've got to use, in this class, I ask you to use an atom inventory. On the final exam, it's not required that you show an atom inventory, but that's how I taught you to do it. If you'll use that atom inventory process, you have a really good chance of being able to balance equations properly. Alright, so we're going to list aluminum and chlorine and magnesium. I'm going to make a kind of small spreadsheet or grid here. And what I'm going to do is count and list the number of atoms that I have of each of these elements on each side of the equation. So the number of atoms on this side go here. Got 1 aluminum, 3 chlorines, 1 magnesium, and the number of atoms on this side I put over here. 1 aluminum, 2 chlorines, and 1 magnesium. And the only thing that I can use to balance the equation is coefficients. Okay, the large numbers in front of these symbols. Now if I've got 3 chlorines on the left and 2 on the right, then it makes sense that I'm going to put a 2 here and a 3 here to try to get the chlorines balanced. That's the only thing that's currently unbalanced. So let's mark this out now. We're going to have 2 aluminums now. This 2 applies to everything in the formula. 2 aluminums, and we have 6 chlorines. And on this side over here, we're going to have 3 magnesiums and 6 chlorines. Okay. Then to get the aluminums balanced, I need to put a 2 in front of this aluminum to give me 2 aluminums. I need to put a 3 in front of the magnesium to give me 3 magnesiums. And the equation's balanced. By doing that now, I've got what I need to be able to write a molar ratio here. I want to have the same species on the bottom here as I have in the top of this. And I'm going to treat these coefficients like moles, so that for aluminum chloride in the equation there are 2 moles of aluminum chloride. So I'll put 2 moles of aluminum chloride here. And since what I'm trying to find right now is the other reactant, and that's magnesium, I'm going to put 3 moles of magnesium on the top. Okay. Now, this allows me to cancel moles here and aluminum chloride here. Now, I didn't need an equality statement for this because this is a molar ratio. I'm going from one species to another. For the this conversion unit here, I did have to have an equality statement to do that. Yes?
So when you do the Molar Ratio, you just go by the coefficients on the left side?
Yeah, well, the coefficients in front of the species you need. Okay, in this case, we needed both reactants because we're trying to find the limiting reactant first.
I thought you were going to put 3 moles of, I thought you would put 3 moles of magnesium for
No, we're not ready to do that. Well, we're not even looking for that. We're eventually going to look for the aluminum solid. That's what we collected at the end. Okay, so now that we've got 3 moles of magnesium, we can convert the magnesium into grams, but we need a molar mass calculation for that. This is pretty simple because all we have is one species, magnesium. So down here at the bottom where I'm listing my atomic masses, I'm going to write magnesium here, and its atomic mass is 24.3050 grams of magnesium equals 1 mole of magnesium. Okay, and that's what I'm going to use now to build this new conversion unit. This is an equality statement, and up here I'm going to put on the bottom here the moles because I want to be able to cancel these moles. So the 1 mole of magnesium goes on the bottom, and the 24.3050 grams of magnesium goes on the top. Okay. Now, anytime you calculate the molar mass, that mass, the sum of all the atomic masses of all the atoms in the formula, that sum is always set equal to 1 mole of that same species. Okay, that's the equality statement. It's always 1 mole. The only time you're not going to be using 1 mole is when you're using this molar ratio, and that comes from the balanced equation. You use whatever coefficients belong there. All right. So now we down at the bottom. Well, this is just the atomic mass from your periodic table. If you need a periodic table, there's one over here. You can. Okay. So now we can cancel moles of magnesium here and here. Okay, and we can do the math. And I've asked you guys to practice this, and I would ask you to practice again. What you want to do is multiply everything across the top to start with. So 12.0 times 3 times 24.3050, that's everything across the top, and hit enter, and then hit your divide key. Divide by this number first, 133.341, hit enter, divide key, and divide by this second number, divided by 2, and I get 3.280986343, and that's grams of magnesium. I've asked you to practice rounding off every time you need to. We need to look at all the measured or calculated numbers in the problem. Now these two numbers here were counted. They're not measured or calculated. We counted the number of atoms in our atom inventory. So we're going to ignore these right here. We're going to ignore all the ones. Those are all counted numbers. The measured numbers, this is a measured number, and this are calculated numbers. And for these numbers, the one with the least digits is this one. So if this has the least digits of the measured and calculated numbers, I want my answer to have that same number of total digits. So we want to underline everything after the first 3 digits and round that off, and we get 3.28 grams of magnesium. Now, in reality, since this test doesn't require you to show all your work, all you really needed was this number. If this number, the amount you calculate of this reactant, is greater than the amount you're given in the problem, you're given 12 grams, this is the limiting reactant. But if this amount is less than the amount you're given, then magnesium is the excess reactant. Okay? That makes aluminum chloride the limiting reactant. That makes sense?